Hi, Joe Cerrone.
Al Rosen.
Welcome to CAD 107 Intro to 3D Printing with our weekly Zoom meeting. Today, we're going to take a look at Lab 9, which is this ring project. If we take a look at this file right here, it's got a YouTube tutorial on how to create the ring.
Project 20. Hi, Joseph.
I'm going to go back. And then if we take a look at the lecture for today, our lecture is on 3D models from our textbook. And so we're going to start with this PowerPoint, 3D models, and it ties into the book. And what I'm going to do is to 3D models, module 7, designing for 3D printing. So as we look at this chapter, the first step in using a 3D printer would be to create a 3D model. And I guess it's not necessarily the first step, but it's the kind of step that we would do since we're using this program and we're using CAD to be able to create these files. And so this chapter talks a little bit about CAD programs and software. It's got some good content in it. If we look at 3D model formats, we'd be looking at exporting the files as an STL file or a stereolithography file. And so the way it works is we would go and we would model the part. And so we have this ring right here that I've modeled for you. And it basically just goes through the steps that we have right here. And so from the textbook, they made this ring and it's kind of a Lego ring. And I thought it looked like we could improve on it. So I did some changes for it. I added some radiuses, and then I took a logo and put it into the top. And I'm going to look into seeing if I can use dual extrusion to 3D print in 2 colors. But I have figured out a technique that we can use to be able to print this with an insert. So as we look at this 3D model formats, the way that we would create an STL file from AutoCAD would be that we would have our part right here. And the way that I have it set up is I have this insert set up in the exact location that it would be in the file. Because when we start to export them and import them into the slicing program, the coordinate data maintains and it's assigned to an extruder head. So we print the ring in one color and then the logo in a different color. Or what we do is we take the components out of it like that, and we print the ring and then we print the logo in a different color. And when we print the logo, we scale it just slightly with something called horizontal expansion. We can also just use a regular scale command. But we scale it down just enough so that it fits in there, because if you have them both the exact same size, it won't fit together, or you'll have to do some sanding. So I'm going to bring that part back, and then I'm going to export this file. So I'm going to say export, and it's going to export it as an STL file, and I'm going to export this to, I'll just say JC-ring. I'm going to just leave it in my downloads. I'm going to click on the large shape of the ring and I'll hit enter. And then I'm going to export the other shape, which is this file. And I'm going to export this one over here because I'm not quite ready to go into dual extrusion, but I can show you how to extrude them and print it with a single head nozzle with 2 different colors, which is actually a lot more practical. So we're going to export this one. And I'm going to export this one as logo. And then I'm going to set and export all of these parts right here. Then we're going to go into our Dremel slicing software. And let me go and say, new project. And then what we're going to do is we're going to open up our STL file. And so we have our ring right here. And then I'm going to open up the logo. And so the logo is located right over there. Now, one thing we want to look at is how we're going to build this. Now, if I slice it by hitting prepare, and what I'm going to do is I'm going to set this up for PLA, low quality, and I'm just going to go ahead and prepare it.
So since you did the correct size, you don't have to scale the ring for the parts, correct?
Well, I do have to scale this piece right here a little bit. And you can see it's really very small. There's not a lot of detail. I kind of lose it a little bit over here.
Okay.
And so one of the tricks that we can do here is to take this and we can scale it down just slightly. Now, what I did was I measured my existing ring that I have, and I got my micrometer from Amazon, $10. And what you want to do is set it for millimeters and then measure it. And mine measures out to 19.8 millimeters. And so what I found was that if I increase the size of this piece just slightly, and so what I'll do is I'll scale it.
But Joe, when you put it prepared, do you scale it individually or does it both scale?
I scale them both a little bit differently. And so I'm going to scale this one up 113%. That was what I calculated it out to be. And then I'm going to scale this one up 110%. And I'm just going to try it. Because it's 3% smaller, it should fit into the area. And then I'm going to prepare it.
Right.
And it doesn't look much different from that quality aspect, but it's good enough. Now, the other thing that I want to do is anything that's on the build plate will have a nice smooth surface. And so it would be much better if we took this part and we flipped it over. And so I'm going to flip this over 180 degrees. I'm going to do the same for the logo, because if I put the logo into the ring, I'll get the build side up, which will be a little bit rougher versus the glass side. So I'm going to click on this, and I'm also going to flip it over 180 degrees. And then I'm going to send it to my 3D printer. Now I have my 3D printer networked. Let me prepare it. And so it says it's 11 minutes, which means I can update the quality quite a bit. So I'm going to go and let's go to a 1 millimeter high quality, and then let's re-prepare it. So that's a reasonable amount of time. 35 minutes should be good. Let's go with a medium quality and see if we can get something that maybe would be about 20 minutes. Perfect. So I have my ring file, I have it set, and I'm going to start the printing, and then we're going to continue our lecture. To do the printing, I've networked my 3D printer. Sometimes I have to click on it a couple of times. There it is. And then what I'm going to do is I'm going to go here and I'm going to say print over network. And so I'm going to say print over network. It's going to send the file to the printer.
And we have to put some glue on there or adhesive, right?
Right. So I did prepare the palette by putting some adhesive on it. We use these glue sticks, and that just makes sure that it holds down to the palette. So the first thing the printer will do is to calibrate the flatness of the palette. And so it's going to start up here, and then it's going to touch off on the top of the palette just to make sure that it's level. Usually I'll go through and change the filament. I probably should have, because the filament has a tendency to dry out and crack. And so sometimes it'll break and then I have to go and reload the filament, but we'll chance it on this one. So while this is running, we're going to go back, and you can see that little probe comes out in the middle, and then it probes, I believe it probes it in 3 rows of 3. So we should get 9 touch points. And there's little knobs on the bottom to adjust the levelness of the 3D print. So switching back to PowerPoint, and I'm not sure, I think I have a different screen up here. Let's see. There we are. So we modeled the part, we exported it as an STL, and we brought it into our slicing software. Let's talk a little bit about some of the other things as far as being able to get our files set up and ready. Let me see if I can make this a little bigger. Scanning is another application, and we haven't really got really heavily into scanning because we're very mechanically orientated. Scanning would work well with something like this rubber duck where it's kind of a organic shape with a lot of curves. You also want to look at the finish of the part. It works much better with dull, flat colors versus shiny metallic ones, because essentially it's a camera that's taking these pictures and creating a digital image of these point clouds. And so scanning is something that we're working on moving towards, but at this time, we're not doing any scanning. We're just bringing it up as a way to create a part if you don't know how to use CAD, or if you have a part that maybe is too difficult to model. One thing that is really neat, and some of the guys did this in our class, was to use an Xbox Connect. I'm not sure if I'm saying it the right way, but you can actually take an Xbox and set it up to create a point cloud, and it actually works pretty well. There's a YouTube video on it. And you can skip the ad. There it is. And so this guy here goes through and walks you through how to create. And there's a software that you download that works with the Kinetic software. It's kind of a plug-in. And then if you've got an Xbox 360, you're all set to go with the Kinetic interface on it. And so we'll look at this at some future point in creating the labs. Oh, after my own heart. I would really like to have Tony Stark's lab facilities. All right, let's pause this and we'll come back to it.
Very good so far.
Okay, so we looked at our scanning and we looked at working with the Kinetic, and there's some tutorials for working with that. And you do want to use some caution, because when you work with scanning, it doesn't necessarily have the same precision as a CAD model does. And so CAD models are much more precise than the scanning. Some other applications, dental and medical applications, are using scanners quite a bit. And you can find applications in the medical industry for creating teeth and false teeth, and other applications where they look at things like bones. Other applications that we can look at would be taking somebody else's model and modifying it. And so Thingiverse is a great place to find models. If you want to model a part on Thingiverse, here's an example of the Iron Man mask. And you can just go ahead and download these files. The authors want you to build them, and so they'll put these models on file, and then you can download those files right here. So you download the files, and it's starting to download, and that's where that will be. Thingiverse is a great place to get models that you can practice for your CAD work. So we use a number of different CAD programs, and some of the CAD programs that we'll use, let me switch this. There we go. We use AutoCAD quite a bit, SolidWorks, and I think the up and coming program is going to be Fusion, because AutoCAD's been around for a long time, and what they do is rather than modify the program, they just go and invent a new one, or they purchase somebody else's program and bring it into their content area. And so you can model these parts using a number of different CAD softwares. The vocational aspect of it is that there are jobs with CAD, AutoCAD being very, I would say it's the #1 CAD software. And then SolidWorks is probably the best CAD software for solid modeling for mechanical and manufacturing purposes, but it's a bit more complex. And then Fusion is this new program that's kind of the in-between, which is sort of a modeler right out of the box, kind of like SolidWorks is, whereas AutoCAD is kind of a 2D drafting tool with modeling aspects to it. So another thing that the textbook talks about is creating multiple extruder files. And we do have the ability to use dual extrusion with our Ultimaker 3D printing machines. And the way that would work would be that you would assign one of the print heads to one of the STL files and the other print head to the other STL file. And by doing that, then the program can go through and figure out which one to print in which color, and you can get a completed part in multicolors. And the way that looks would be on the next slide. I'll come back to that last one, where you would have like this dice piece. And what you do is you create the model, and you create them on different layers or in different display states if you're using SolidWorks, so that it maintains the relationship. You can see that these 6 pegs here would line up in space with these 6, and then these 3 holes here line up with these 3. And so as far as the 3D printer is concerned, it knows which ones are which by assigning the print head. So I'd assign print head 1 to this STL model, and then print head 2 to this model. And you can see print head 1 was printed in black, and then print head 2 was printed in white. So this is a really awesome technique. You can download these files from Thingiverse if you put in dual extrusion models. Another thing that you can do is you can use dissolvable support material. And think of dissolvable support as kind of like Elmer's glue. It's water soluble, and so that's kind of what they liken it to. It's almost like kind of a hard Elmer's glue that will be extruded in the points that would be removed or would not be needed, because you can't just print in midair. And so you have to have each of these layers built up one at a time. And so what it does is it builds the layers for the dissolvable material like it's shown, and then you take the model and you put it into a tank, and the tank has like an agitator in it and a warm bath, and then it will dissolve the dissolvable support material. And so it's printed complete. It's really kind of a neat process. So that's the summary for this chapter. This chapter goes through some CAD modeling aspects. It does have some good techniques on how to do a dual extrusion model that you should take a look at. And that completes this part of our lecture. Let's take a look at how our 3D printing is going.
That'd be fantastic idea, Joe.
And at this point, what I can see is that the platform temperature is at 60. The chamber temperature is at 29 degrees Celsius. And it should be, the cameras kind of, sometimes they don't necessarily update as quickly. So I'm not sure if it stopped. It has. My filament broke. So unfortunately, I'll have to come back to this point. That was one of the concerns that I had. So we'll come back to that at another time. All right. So with that, let's go back to our main page for this week, Lab 9. You're to model the ring. And if we go to the content section, Lab 9. Here's the ring project. If we download that and take a look at it, I've already downloaded it. It's right here. We're going to model this ring. It's got the sizes. And what you could do is you can make some modifications to it for your own size. What I'd recommend you do is measure an existing ring that fits and see what that is in millimeters. And then you can come back here to your CAD. And in the tutor file, we have this set up so that I model it each step of the way. And you can do a different insert if you like. You can come over to this point and model it with an insert. Maybe you want a big A for Al. Or maybe you want AR for Al Rosen, or maybe you want something else on here. And so you can decide what you'd like to model on there if you don't want to use the Oakton logo. And then if you look at how it's made, what we do is we start off in the top view. And let me type in plan because it twisted on me. That way my x-axis is correct. And so this is the basic shape. And this is how we started to model this based on the geometry. We model it flat. I would probably make this 19 millimeters, and I'd have to increase the outside respectively so that it would fit on my hand. And then we trim. And then once we have that trimmed, we'll take that and we'll press pull it into a shape. And then once we have that, we'll 3D rotate it. And then I've gone through and shown how to put in a logo and an insert. And it's a little bit, to be able to do that, we would go through and put the sketch onto the top plane and then press pull it into the part. So for example, if I wanted to put a logo on this part right here, I could go here and I could draw a circle. And it's a little difficult. I'm just going to kind of eyeball it. Well, maybe I won't. Let's see. Yeah, I'll have to put a 3D face. There we are. And then if I wanted to put a circle on here, and then press pull that, we could press pull that in, let's say 2. And then I could have that geometry and then print the other geometry as a solid like we have here with this part. So you're welcome to modify the ring to make it to your liking or to make it to your own initials. Put a big diamond in it if you want. We don't have the ability to print out of metal, but there are filaments that are that do have some metal like flakes to it. So you can find things like brass and copper filaments or metallic filaments that look really quite great. Okay.
Or even wood style.
What's that, Al?
Wood ring.
Yes, you can. You could make a wooden, they do have wood infill, which is, and it actually smells like wood. So as you're printing it, kind of has that pine forest smell. Okay, so that's this week's review and Zoom meeting. We'll see you next week online.
Have a nice day.